On page 6 in your handout, you can read about functions that are not well behaved. What if you try to figure out this limit just by substituting in that x value? And we'll end up with a negative 1 plus 1 in the denominator, which leaves us with an undefined expression. So you can use the same old algebra tricks you've known for a while. You can simply rewrite this as the limit as x approaches negative 1 of, let's factor the numerator. This is 2x minus 3 times x plus 1. I'll leave it up to you to review your factoring in whatever way you need to. Over x plus 1. The denominator can just stay the same for a moment. Notice that I can simplify by canceling out those common factors. And what I have is that this expression is equal to the limit as x approaches negative 1 of 2x minus 3. Now when I go to plug in negative 1, there's no problem. It's going to be 2 times negative 1 minus 3, which makes negative 5. For the second example there, I have a similar problem. If I tried to just plug in 16 for x, I'm going to end up with a 0 in my denominator. So we can use a technique called rationalizing the numerator in this case. You probably remember rationalizing a denominator if you were left with a radical expression or maybe a complex number in your denominator. Here we can multiply top and bottom, not by the conjugate of the denominator, but the conjugate of the numerator. So the conjugate, remember, of a binomial is an exact copy of that binomial, but with the opposite sign. So I'm going to multiply top and bottom by square root of x plus 4. Square root of x plus 4. So just a hint, you don't have to do the multiplying out in the denominator here. So watch what happens. That's going to equal the limit as x approaches 16 of, when I multiply in the denominator, I'm just going to write this as x minus 16 times square root of x plus 4. In the numerator, I'm going to multiply that out. So radical x times radical x is regular x. 4 times square root of x minus 4 times square root of x will cancel out. That's the whole reason I'm doing this. So my radical term cancels out and have minus 16. And now watch what happens. I can cancel out. I have an x minus 16 in the numerator, cancels with an x minus 16 in the denominator. My new problem, this is the limit as x approaches 16 of 1 over square root of x plus 4. I'm going to come to the top here. Now I can plug in 16 without having a problem, without making a 0 in the denominator or any other problem I can't recover from. So that's going to be 1 over the square root of 16 plus 4, which is going to make 1 over 4 plus 4, which is 1/8. Here, this last example, our technique in this case is going to be to get a common denominator in order to simplify this complex fraction. Remember, complex fraction is a fraction that contains fractions. So we want to rewrite this so that we can do one single division problem. So I'm going to multiply that first fraction in the numerator by 4 over 4, the second fraction by x plus 4 over x plus 4, and you can see I've started to simplify here on the next step. This is going to give me the limit as x approaches 0. I still have that x in the denominator of the big fraction. Here, my two fractions in the numerator do have the same denominator. That's the good news. X plus 4, that's a 4. And now I can actually just subtract in the my two numerators here, so that's going to be 4 minus the quantity x plus 4. Make sure that subtraction sign gets distributed. So now how can I divide a fraction by a fraction? I'm going to multiply by the reciprocal of that denominator. The reciprocal of x is 1 over x. And we can see that this x here in the numerator and the x there in the denominator will cancel each other, leaving behind a negative 1. So I've got a negative 1 over 4 times x plus 4. Now when I plug in 0 for x, I'll just get no problem at all. Negative 1 over 4 times 0 plus 4, which is just negative 1 over 16.